Okay. Okay, we're gonna do rational exponents, lesson 3. Can anyone tell me what the word rational means? Rational is any number that can be written as a fraction. So what type of exponents do you think we're looking at? Fractional exponents. Okay? All right. So, first thing we're going to do is we're going to write the following expression using exponents. Okay? Here's how you do that. The base is always going to be the bigger number that's underneath, so that's going to stay. Your fraction you find by rewriting the exponent on top and the root number on the bottom. So this would be u to the third 3/7 power, or the power of 3/7. Okay. All right. Blakely?
So 3.
And what would be your exponent? What would be your fraction as your exponent? 2/5 or 5/2?
2/5.
2/5. Good. Okay. The exponent goes on top. The root number goes on bottom. Okay. What if it looked like this?
It'd just be x.
Nope. They're still a fraction. Gunner?
It'd be x, and then it'd be 0.
Uh-uh.
X
One.
1.
Listen, it's still a fraction. What exponent does x have underneath the radical?
1.
1. Okay. And what root are we taking this to? Yes. If we don't see it, square root is always to the second. Okay? So, square root would just be 1/2. All right? Now, we can go the opposite way. What if I have x to the 1/3 and I want to write that in radical form? Can anyone tell me how I would write that using radicals? Olivia? Oh, Stone?
X to the first power.
Okay. Do I need to put to the first power?
No.
No. Where do I put 3?
Outside.
So the cube root of x. All right? What about x to the 2/5? Tate? X to what power? Okay. 5th root. All right. Last one. Caleb?
14 to the first power.
Okay.
And then 7 comes out.
Good. All right. Everybody understand that? Top of the fraction is the exponent. Bottom of the fraction is the root you're taking it to. Yes? Okay. Now, we're going to talk about real quick how you would evaluate that. So, if I have 125 to the 3rd power, the first thing I would do is write it as a radical. Can anyone tell me how I'd write that as a radical? Psi.
125.
Okay. Then, how would I solve that?
125.
Oh, it's 5.
Okay. Yeah, now some of you already know what it is, but I'm going to show you for ones that you don't on your calculator. The first thing you need to do is tell it what root you're taking. So you would type 3 first. Okay, then over here you have to push the second button and then go down to the arrow. It'll pull up a square root with an x in front of it. If it doesn't have the x, then you're taking a regular square root. Okay, all you do is type in your number after it and it will tell you that the cube root of 125 is what? 5. Okay. Did everybody find that?
Yes. Yeah, 525.
Who said no? You got it? Dell? Okay. Yes? All right. So, what about 81 to the 1/4 power? Stone, how would I write that?
81.
What root?
4.
Okay, to the 4th root. Same thing. You can type that part into your calculator, or some of us should know that it's 3. Okay. Some of these you're already going to know, so that's fine. Okay? Now, what if it is like this, 16 to the, with an exponent of 5 over 4?
You just put it up.
Okay, we already talked about how to write these. How do I write it? 16 to what root? Okay, now, to solve these in your calculator, I would put the fifth power on the outside. It's going to make it easier for you to type it in your calculator. I know on the other ones we wrote the fifth underneath. It does not make a difference, okay? This will just make it easier for you to solve, right? So, what is 16 to the fourth root? 2. So you take the fourth root first, and then you would take 2 to the fifth power to get what? 32. Okay? Now, some people have been typing the whole thing in their calculator, which is fine, but you have to be careful about how you type that in. I would recommend doing 2 steps. It's not going to be difficult for you to write those 2 steps out, sir.
If you were to do the whole thing, would you have to split the parentheses?
I would, yes. Because you have to tell your calculator what. Here's the deal. People always say the calculator is always right. True, but you are telling the calculator what to do. So if you don't tell it what to do correctly, then the calculator is going to tell you the wrong answer. Okay? So, I don't care if you put it in all at once, but just be careful about how you type that in. Okay? Alright. I think we're okay with that part. Let's look at negative exponents.
I don't think it makes
Well, let me do this one first. Okay, anybody want to try this one? Stone, what do you think?
Calculator.
No, don't use your calculator. Not yet. Would you work it any different than the ones when we did a whole number?
No.
Okay, let me ask you this question. Is square rooting 1 and then turning around and squaring it going to do anything?
No.
So do I really even need to worry about the 1?
No.
No, I'm going to leave it the same. What would you do on the bottom?
145 and 235.
To what root?
3.
And then you would square it. Okay? What's the cube root of 125? 5. So I have 1 over 5 squared, which would be equal to 1 over 25. Okay? So it's the same idea. The only reason we don't do anything to the 1 is because we know that's not going to change. All right? Now, this is a little bit of what we talked about yesterday. What happens if I have a negative exponent? How do I make it positive?
What is it?
Okay, what would it be?
3 over 2.
No.
No,
64.
1 over 64.
64 to what power?
Negative half.
No, the exponent, listen, the fraction does not change.
Oh, yeah.
The only time that you are flipping something is, remember when it looked like this? You had 1/3 to the negative second power. Then you can flip 1/3 and change it to a positive exponent, okay? That's the only time you flip it. Otherwise, the exponent stays the same, okay? So now it's exactly like the problem we just did, right? 1 over 64 to what root?
3.
Cube root, and then you're going to square it, all right? What's the cube root of 64? Gunner?
4.
Yes. And 4 squared would give you 16. Okay, again, some of you know what those roots are already. If you don't, you can use your calculator to help you. Okay? Good with those. All right, here's the last type of problem. Is everyone okay up to this point?
Yeah.
Okay, here's where I really need you to pay attention, because this is the part where people get confused. It's not difficult, but you have to pay attention to what it's asking you to do. Okay? Steele.
I'm ready.
Oh, you're wanting to answer it?
Yeah.
Okay, I'm going to start with an easy one first, so you kind of have the idea, okay? It's wanting us to solve for x. Okay, so what I want to know, this is a basic problem, right? What I want to know is what exponent for x would give me a value of 243. Now here's how I'm going to solve. What I want to do is change this to be an exponent form. So I want to know what number was that before we got to 243. And you want to have the same base number, okay? What base number does this have? 3. So shouldn't I use a base number of 3 here? Say yes.
Yes.
Yes. Okay. Can anyone tell me 3 to what power is 243?
5.
How do you know that, Blakely?
Work it in
Use
15.
numbers.
Yeah, tell me. How do you know? Because you plugged it into your calculator. Did you get 5 the first time you tried it?
No.
What'd you try first?
Try 7.
Okay, and it was too big, right? So sometimes you might have to just guess, but if you know what the base number is, then you can find that exponent. Now, once the two bases are the same, all you have to do is set your exponents equal to each other. So you would get x is equal to what? 5. Okay? I'm going to do a couple more because, again, they get a little bit more confusing. Okay?
I got this.
Okay? All right, Steele.
So, you're gonna
The first thing you want to figure out is you want them to have the same base. Okay? What base number do you think we're going to use here?
use 9.
Okay, let me ask you this question.
Three.
Why can you not use 9, Steele?
Because 9 to the second power is 81.
Yes. Okay, does everybody see that? The first thing he thought was the left side says 9, so if I use 9 to the second power, that's 81. So it's not 9, so we're going to use 3. So 3 to what power is equal to 9?
Squared.
3 squared. Okay, there was already an x in the exponent, so we multiply that.
And it would
3 to what power is 27?
3.
3 to the third power. Okay, so listen, all I am doing is changing these numbers back to exponent form. Okay, does everyone understand how I got 3 squared and 3 cubed? Does anyone not know how I got those two numbers? Some of you are looking but not saying. What, Si?
Okay, so you got 3 squared, but why do you put the x after?
Because there was already an exponent here. So you're going to have to multiply those two exponents together. Okay? The other one didn't because we didn't have it. When we changed 3 to the 5th, this didn't already have an exponent. Okay?
So is it x equals 6?
So, listen, now all you have to do, if the bases are the same, you set the exponents equal. So you get 2x is equal to 3. What's the only thing you would do to solve for x? Divide by 2. So you would get x is equal to just 3 halves is 5. Okay? I'm going to do one more, and then I'll let you go. Okay? Okay, again, the first thing you need to figure out is what is going to be your base number for 32 and 64. Okay, so 4 cubed would give you 64. What about 32 though? Does 4 work for 32?
No.
So what should be, Joe? 2. Okay, so Joe, 2 to what power is equal to 32? You can check it in your calculator.
5.
Did you say 5th? Yeah. Now, what should you put after the 5? What was already there? Negative x minus 5. Okay? If I change 64 to have a base of 2, what exponent should I have? 2 to what power is 64? Check it in your calculator. Do 2 to the 6th power. Are we checking that or just
I
guessing?
checked it.
Okay. All right. Blakely, do you know how to solve from here?
So 5 or 5 parentheses minus or negative x minus 5 is equal to 6.
Good, because the bases are the same, so we set the exponents equal. All right? Okay, then solve. So you'd get negative 5x minus 25 is equal to 6.
Add 25,
What's 25 plus 6?
31,
Okay, so I would get negative 5x is equal to 31,
5 and negative 5.
and just divide by negative 5. Okay, listen, the most difficult of this part of these problems is just identifying the correct base, okay? Because once you get the correct base and you set this equal to each other, that's easy stuff for you to do, yes? So the most difficult part is for you to identify the correct base and then go from there, all right? But everything else on your work, you're gonna roll through pretty quick, yes? Okay, any questions?